So multiplication rule was for A and B. The addition rule, on the other hand, is for A or B, which is A union B. So if you think about it, multiplying, we just distributed multiplication. Here we are adding, so what should we do? Add the probabilities. That's what one would think. But you got to take that off. So why? When we compute the probability of A, we will count an event. And when we compute the probability of B, we'll count an event. So in total, we will double count the event. So we're going to take one of the two by subtracting. So if A and B could happen together, then it is going to happen here and it is going to happen there also. Do you agree? If they happen together, you're going to count it here, you're going to count it there. You double count it, so you've got to take one off. Good. So that's where this rule comes from. Luckily,
so what are you doing in the union of them? Are you multiplying them?
give me 1 second. You mean here?
Yeah.
I'm trying to find the probability of A or B. And
So that's or, and then the other one is and?
this is also, oh, you mean this one?
Yes.
This is and. Yes.
I'm like blanking on like my 3 hours.
So if the events are disjoint or mutually exclusive, then what is the probability that A and B could happen together?
0.
0, because I just said they are mutually exclusive. In other words, they cannot happen together simultaneously, but I'm wanting to find the probability that they would happen together. That probability will be 0. So if you know that the events are mutually exclusive, then probability of A or B is simply the probability of A plus the probability of B. This goes back to the 4 ways that Sarah wanted to know of. The 4 ways that we wrote last time. At any given time, only one of them would happen. Yes? Any combination of those will not happen together. So all of those events are disjoint, which is why we simply added the probabilities. If you add 4 probabilities that are alike together, what do you get? 4 times that one probability. That's how we got that 4. Does it make sense? So can you think of an example for mutually exclusive events?
Rolling the dice and getting a 4 and a 2.
Rolling 2 dice, getting a 4 on 1 and 2 on the other.
You can't get a 4 and a 2 at the same time at the same time. Right, to put a 4 and a 4.
What?
I'm going to put 2 and 4.
So if you roll a die, you can either get a 2 or a 4, but you can't get 2 and 4 simultaneously. So that probability is going to be 0. They can't happen together, which would make them mutually exclusive. The occurrence of one will prevent the occurrence of the other. If you get a 2, you can't get a 4. If you get a 4, you can't get a 2. Can you think of another example? No?
So we're basically just saying something that could never happen.
together.
A week and a singular.
You drop a block off the roof, and then you drop another block off the roof. A full minute later, they're not gonna hit the ground at the same time as the first one that's already hit the ground.
It is a valid example.
It is. No,
Uh,
I got it.
But I'm not going to write all that. But it is a good example. Did you follow the example?
Yeah.
You drop the first block, 4 minutes later, you drop the second block. And we want to know the probability that both of them would hit the ground simultaneously, assuming that the weight of the block is the same.
Gravity doesn't exist in the situation. That's not what I meant. Gravity does exist, but like the one is just already at the ground, so like they can't accelerate, you know? Nah.
Mind blown. Moving on, can you think of another example? Something simple.
You know, the bubblegum machines, the
Yes, go ahead.
sorry, go ahead.
If a heart stops, you can't live. Fair enough. Just saying.
They're being alive.
We can really say anything then. You have no hands, you can't write. You have no feet, you can't walk. Have no mouth, you can't eat. This all counts.
So if two events cannot happen simultaneously, those three cases are good examples. There are more. Then we call them mutually exclusive. Mutually exclusive is something that we arrive at based on a logical statement. But where does the word disjoint come from? Could a number be greater than 6 and less than 2
No.
simultaneously?
No.
No, right? So if I want to find the probability that x is bigger than 6 and x is less than 2 simultaneously, it's not going to happen, right? That probability is 0. On the number line, if you draw this out, 1 is going that way, the other is this way, there is no overlap. That's why we call it disjoint. So the disjoint part comes from set theory, the mutually exclusive part comes from logic. Good? Yes.
Quick question for B and
So this one and that one? Or
no,
this one and that
B
one?
and C, yeah.
Yes, that is also a good point. So if B happens to be the complement of A, then probability of A intersect B will be probability of A intersect A complement, which is intersect A and A complement occurring simultaneously. 0. However, if you go here, we want to know the probability either A happens or its complement happens. It will simply be the probability of A, probability of B, which is a complement, but the last part cannot happen, so -0. You'll simply get probability of A, that's the probability of A complement. But what is the sum of those two?
1.
To go with the information it provides to us. So 12 students are physics majors, 16 of them are female. Out of those physics majors, 3 of them happen to be female. So I can partition this as 9 male majors and 3 female physics majors. So how would we go about doing this? We could call that event A. We could call that event B. Yes. What is the probability of A or B? Simply the probability of A plus the probability of B minus the probability of A and B. So this part, could they happen together?
Yes.
Yes. How many ways?
Three out of
Three. Now, here is the question, did we total this? Did we total?
Yes.
And that adds up to what?
28 out of 40.
20, what? 28, right?
Yeah.
So should you put the denominator to be 28 or 40? 40, why?
That's the total.
That's the total. We do not know about the other people, right? They could be chemistry majors, they could be something else. So it has to be with respect to the total. So 3 out of 40. Randomly chosen student is a female, 16 out of 40. Physics major, 12 out of 40.
25.
25 out of 40. Does that make sense? Again, in a problem like this, if you don't, or if you get a number bigger than one, when you do addition rule, you made a mistake. You are double counting, okay? So that is always a hint. So we will do